Hello, everyone. My name is Thomas Rush. I'm going to talk about indexing the Ethereum mainnet, and importantly for me, how to index the Ethereum mainnet without becoming a Web3 API provider. That's very important to me. So, first of all, I wanted to ask if anyone's donated to my Gitcoin grants in the past. A couple of you, I wanted to thank you. I was going to announce a token, but I'm never going to announce a token for my project, so sorry about that. But, so I have a long history in the computer field. I've been doing computer science since 1979. So I've seen mainframe computers go to desktop. I've seen desktop go to web. I've seen web go back to mainframe, basically. And I hope what we're seeing now is mainframe back to desktop. So that's what I'm going to talk about. I believe, so my driving vision, this is an Avado box. Do any of you have Avado boxes or DApp node boxes? So you're running your own Ethereum node, and it's running on this machine. Basically, you buy this box and you plug it into the wall, and you can run an Ethereum node yourself. So there's a node called Aragon, which allows you to run what's called an archive node, which has all the data that's possibly available on the Ethereum network. And the software that I built wants to live behind this box. I want to only communicate to this box and the Ethereum network to get the data that I'm using in the application. So that's kind of the driving force. The reason is because when I joined Ethereum, or when I first got interested in Ethereum, everyone was talking about these ideas of self-sovereign data, perfect instantaneous accounting on every transaction, which is on the chain. But if you try to pull that data off the chain, you may have discovered that you can't really balance your account. You can't really do that off-chain without going to a third-party site, which to me never made any sense. I want to build a piece of software that can reconcile directly from chain data. Because I think we can build what we used to call truly transparent or radically transparent organizations, where any person that's in the organization can do the accounting for the organization, can see what's happening on the organization without having to go to the organization to get the information. Because in that way, we used to believe that we could do coordination on a massive scale, which is an organization that can't lie to us, which means that we, which means that we all have a belief that the organization is behaving the way that we want it to behave. So that's kind of where I'm coming from. And I'm going to talk about my work on trying to use the node software for the source of data and finding that the node software doesn't really give you the source of the data you need. And then how, once we get that data, how can we use it in a way where we don't become a Web3 data provider? So we built a piece of software called Shifra. It's called TrueBlocks, the whole software package. There's a command line called Shifra, and it provides a bunch of different sub-options, one of which is called Scrape, that I'm going to talk about, one of which is called Init, another called Export. And then what we did is we took the RPC data, or the RPC endpoints, and we expanded them and kind of added features to allow us to do an indexing. So one of the commands is called Shifra blocks, and we added an option called unique, which will look at the entire block data using the RPC and extract every unique address in the block. And what we do is we say, where did we find this address? So here we found it in a log. Here we found it in the input data, which is a thing that I think most indexers don't do currently, which allows us to actually get more data than other indexers get. So you can see we're looking at very obvious places like the from and the to, and where a contract is created, but we also look into the input data and the log data. And we're finding things like this, where Solidity has created, this is clearly an address. This is clearly not an address because it has a huge number of zeros. That's probably a number. This is very clearly an address, so we call that an address. even though we don't really know it's an address. So we took 200 of the top Gitcoin grants at random, and we ran it against Etherscan, asking against all 5 of Etherscan's endpoints, can you tell us what transactions happened on those addresses? And we got this column of numbers. Then we ran TrueBlocks' indexer as well, and this is the difference. And in every case, all 200 cases, we found more addresses than Etherscan was returning. Enough so that, excuse me, I'm sorry. Enough so that every time we try to reconcile these accounts, they actually balance down to every decimal place in every transaction, which is not true of Etherscan because there's missing transactions. So we get about 115% of the total number of transactions that Etherscan reports, and we always get more transactions than Etherscan. And we're finding, obviously, that about 60% come from input data, and another 20% come from log topics and log data, and another 20% come from traces. So we've built basically a better index. And we did that because we want to find every appearance everywhere on the chain because we want to create radically transparent organizations. And we are able now to reconcile these histories of transactions down to 18 decimal places for every transaction on a thing. So now we want to publish. We want to say, this works well if you have this box, but can we give this index data to people that don't necessarily have this box? Because the index is very useful to people to build applications with. Even if they're hitting against the Infura node or something like that, they're hitting in a much more targeted way, so they're not rate limited as much because they're not asking for as much data from Infura, for example. So we looked at existing solutions. There's basically two types of solutions. One is a web API like Etherscan. Another is a coin incentivized thing like the graph. And they have these problems that we wanted to try to solve. Web APIs have privacy invasion kind of built into them. You can't go to a web API without having an API key or exposing your IP address, basically. So they're inherently going to be able to, in the future, watch what you're doing, which to me is a really bad design. They also have the ability to deny you access to the data. For example, rate limiting is one way, but they could also say, we don't like you, we're not going to give you the data if they want. They're also creating data that we call unreproducible, which means that they do the extraction from the chain, but they don't show us their work. They don't show us how they did that extraction, so there's no real way to know that the data that they're giving us is accurate, especially given that we can't reconcile the data. So that's a real problem for us as well. Coin incentivized systems, to me, it's kind of like, I've already paid for this data, as our whole community has already paid for the data by gas. Why do we have to pay again to get access to the index that should be, I think, part of this node? It isn't part of this node, but it could easily be, and we should make it part of this node, I think. The other thing is that if you have to pay to play that game, if you don't have money to pay, you literally can't play that game, which means that if you don't have money, you're not going to get access to the index that you want. You're going to compete with people that are going to pay more for their data, and you're going to get priced out of that market. I also think it's way complicated, way unnecessarily complicated, because they're not making reproducible data. They have to build a system where they have an arbitration, they have disputes, they have resolutions, and this ultimately falls back onto the graph. And to me, that's just as bad as a Web 2 site that isn't proving their data. So we wanted to build something that answered these questions. These are the questions we were trying to work on. Can we actually take advantage of Web 3 to solve some of these problems? Can we build an index that's uncapturable, unlike a web API? If we build applications that are truly behind a node, we've built an application that's perfectly private because I don't expose my IP address to anyone except for this node, which is in my control. I wanted to see if we could build something that worked better if we got more users, unlike a web API, where every time you get a new user on a web API, you have to somehow provide more resources to handle their requests. And you have to, that's just built into Web 2 technology. We wanted to make it so users didn't have to do anything, basically. They just have to use the software and it automatically does this. We wanted to make it fair so that a user like Uniswap, who has a transaction in every block, is using the chain more heavily, so they should kind of carry the responsibility of the index more thoroughly than someone like me, who interacts on every 3,000th block or something, so I should carry 1/3000th of the burden. Can we make our results reproducible so that people don't have to trust that we build this data correctly? And then really importantly to me is how low can we get the cost of publishing this index? I hope I can show that it goes almost to zero, the cost of producing and publishing this index. So this is a block, and we've done Shifra blocks unique, and we've extracted the list of all the addresses in those blocks. A regular indexer is going to simply sort that list. The trouble with this, and what we wanted to do is we wanted to try to put this data onto IPFS. So this list is immutable, it never changes, so we can easily put this on IPFS. This list, every time we add new records to the sort, we have to resort, which means that this IPFS hash changes every single time we add new data. So what we did is we basically stopped adding data periodically. Every 2 million records, every time we get 2 million records in this sorted list, we stop adding new data. We write it to IPFS as an immutable hash. And we call that thing, it does the command Shifra scrape. So you can just get our software, run Shifra scrape, and it's going to create what we call a time-ordered log of an index of a time-ordered log. So that's what we built, basically, because we wanted to have immutability built into our code. Additionally, when we go from here to one of these chunks, we put in this chunk, we put the instructions that we used to extract and build this chunk. And we do that by putting the git commit hash of the code that built the chunk. So when you download the chunk, you get not only the actual data, you get the git commit hash that built the chunk, and you get file formats and enough information for you to reproduce the entire data set. Okay? And then we, old-fashioned web APIs simply give this indexed thing to the end users. We wanted to give chunks, so we have this Shifra export. And we can build a piece of software now that lives here behind the node. And I think improves the situation somewhat because at least we're proving our data or we're making it reproducible. So we write each individual chunk to IPFS. And then as we go, we're keeping a list of all the chunks, and we write that to what we call a manifest. So each time we add a new chunk, we write a manifest. We also write that to IPFS. And then we publish this hash to a smart contract that we call Unchained Index. And in this way, we've completely removed our ability to withhold this data now, because we've put a hash to an IPFS file that has a hash, that has hashes of every piece of the entire index, is available to anyone who wants to look at the Unchained Index smart contract. And now you can run either your own receiver of this data, or you can use our Shifra init to read the smart contract, find the manifest, download the entire index to your local machine here. And now you're able to use the node in a way where you can access any piece of data you want about any address that you want completely locally, which was sort of our goal. Is anyone with me here? Except for James. Then on top of Shifra, we built a server, which is literally identical to the endpoints of Shifra, so that you can serve applications. So I want to just pause here and look at this and ask, how much does it cost us to run this system? So we're running this box, we're running Aragon on this box, we're running TrueBlocks on this box. All of this stuff from here to here runs literally for free, or for however much it costs me to buy that box, and how much it costs me for electricity, which is nothing. So I can publish this thing right here for free. It costs me nothing to build this. I want to build it because I want my application software. I'm going to sell application software. I want my application software to have access to everything they want in my application software. So we do have one cost, which is publishing this manifest to the Unchained Index. We have gas costs, but they're extremely minimal because that smart contract does nothing but accept the hash. So it's very, very cheap. So any human being on the planet Earth can look at that smart contract, pick up that manifest hash, pick up all of these hashes, and download the entire index of Ethereum's mainnet for every address on the chain, literally for no cost. So that, to me, is important. It's interesting. It's a direct result of IPFS. It's not that we've done anything special. It's just that we've used IPFS in the way that IPFS is built to be used. It has some other interesting aspects. If this user is me, I'm going to look at this and say, I don't need 80% of these index pieces. I need 1 or 2 or 10 or 15. I'm going to download them here and pin them on IPFS. By default, we do that by default, so that this user becomes part of the solution of distributing the index, because he's downloading his part, he's downloading his fair part of the system, and he's making it available to other people. Because it has 2 million records in it, only 10 of them are his. Now, the one trouble we had here is this index is 50 gigabytes big, which is a little big. So we also added a bloom filter on top of each of these immutable chunks, which is an immutable bloom filter. And we also put that in IPFS, and we put that in our manifest, and now it becomes 1 gigabyte. So when a user comes and says, I want to participate, they download 1 gigabyte of data on their hard drive. They can do a query that says, which pieces of the index do I need for my address? And they can read it from here, look at all of the blooms, and only download the big pieces that they need for their uses. So you get a fair system where tiny users or regular people download their own fair share and pin it, make it available to others. Large users get almost every piece of the index and pin it and make it available to users, which to me seems fair. And if it's fair, I think people will tend to want to use it because they're not feeling that they're taken advantage of. So, so this is kind of, it all works. I have a demo, but I don't have a demo, so I'm just going to wave my hands. But so did we take advantage of Web 3 kind of in a get rid of Web 2 and all of its problems? Let's just see what it looks like to build a Web 3 thing. Yes. Can we make it uncapturable? Not really, because we have to publish the manifest hash to the smart contract. Although if we disappear, anyone could do that. 2 minutes. Is it private? Yes, it's private because it's behind the node. It works better. The more users you get, the better this works. which is an outcome of IPFS, not of us. The users don't really have to do anything because it all works by default, and you just have to have an application that wants to read this data. It's equitable, it's reproducible, and it costs nothing, believe it or not, or next to nothing. It's so cheap that I'm willing to build it and give it away for free because I want my applications to work. I want my applications to be on a node, and I want it to work, and I'm more than willing to give it away for free because it costs me nothing anyway. So I don't understand why everybody wants to have a coin incentivized network where we have to pay for something that we can literally build ourselves for free. And I think we should do this. Demo. The demo shows that there's no reliance on third parties. We can cache the hell out of this data because we're on a local machine, so we can make it as fast as we possibly can because we don't have to go across the network repeatedly. We go once across the network to the node, and then we cache it locally. This works with Infura as well. You'd be surprised at how fast reading from a hard drive is when you don't have to compete with 10,000 other users on a server to read from a hard drive, and it's perfectly private. We can get every transaction and reconcile them. We can actually surprisingly find every token that you've ever owned and show its balance history because we can see every single incoming token. This is a very interesting thing. The application becomes user-centered. So instead of me wanting to understand what happened on ENS and having to go to ens.io, or wanting to know how to interact with Uniswap and going to uniswap.io, which is a privacy invasion, I can see everything I've done here and just walk through my transactions interactively. And the thing almost becomes like a spreadsheet instead of a web page because it's so fast, because all the data is local. So just think about Infura for a second. Am I done? I'm very close to done. We have a front-end work that we're doing. We're working on a Docker version. We love Aragon because it allows custom stages. So we think that part of this work can get put into a custom stage in Aragon so that it runs this scraping mechanism. And we have this idea of traversers, which is, the graph does have a great feature where you can look at each transaction and modify it in any way you want. The indexer can, but we can actually do that here. After the extraction, we can customize the data in any way that you, the developer, wants to provide to your users. I think it's really important that we all start thinking about running our own node software because to me that's decentralization, is what's the point of what we're building if every user has to come to a website to use our tools? It doesn't make any sense to me at all. We should think about running our own nodes. If we do, we're going to find that the node doesn't really deliver the data, so you need an index. So I'm suggesting that TrueBlocks is one possible solution to that. And then we can build what I call truly distributed, perfectly private, local first applications, which I think we should try to live in that world because we want to understand what those applications look like, and we want to see what we have to do to make those applications work for users. There's contact information, and I'm done. Thanks. Do we have no time for questions?
Yeah, I think it's...
You can hit me up outside.